We're getting into lesson 4.10. Here's another formula. And again, this should be on your formula sheet. But the thing to note here is that you have two tangent segments, and the distance from their point of intersection to the point of tangency is the same. These are marked equal lengths here. Sorry, I probably sound kind of weird today, or I'm trying to make it through this. I also have a sinus infection, I found out yesterday. So if I sound a little strange or have to blow my nose, that's why. But I have medicine now, so it'll be better. It will be better. You'll also talk about chords. We had a picture similar to this on Monday, but we were talking about the angles inside here, the vertical angles. This one's actually talking about the lengths of the chord, the pieces of the chords. So we have from A to E times E to B. So you multiply those two pieces is equal to C to E times E to B. So that's, I don't know, in a way it kind of reminds me of the triangle, the splitting, side splitting theorem. That's what I'm trying to say. Oh, goodness. It's been like Emma said, it's been a long week already, and it's only Wednesday. It's just, we had spring break in there. I think we forgot everything, right? Okay, but that's something important to note. So if you have like 3 of these lengths and you need the third one, this would be a helpful formula. Or even if you know like 2 of these pieces and then maybe like the total length, you could write, like for example, and we will definitely do some examples, but let's say you knew the entire length of CD was 10, you could write this as x and this one is 10 minus x. So that's one way you could use that formula, even if you don't have one of the individual pieces. All right, so here is one, and that's actually going to go with this formula here. Okay, so we don't have an example actually of this one, and for the most part, I think the two on the previous slides, this one and the one right before this, are fairly straightforward. They don't give you too many that are super tricky. But let's just make one up. Let's say that they told you AE was 6 and EB was 3, and then you had the information on the screen. You could say 6 times 3 equals 10 minus x times x, and solve it that way. And I don't remember off the top of my head if you have one like that, but I'm just kind of trying to show you a technique that you could use. It doesn't come up a lot, but if they give you the entire length, that's what I'm trying to show you here. If they gave you this entire length of 10, you could still use this, because a lot of students, you know, you'll stop and you'll say, well, I have 2 pieces that I know. I know this and I know this, but I don't know anything about these, so I can't do it. But you really do, and this is how you could set it up. Okay, so hopefully you won't get one quite that hard, but if you do have the skills to solve it. All right, so 4.11, let me change your polling tools. The formula is up here, and this formula is written from this example, but this is in general how you would look at this formula. The whole segment times just the outside piece, the part that's outside of the circle, equals the whole segment times the outside of the circle. So AC is the whole segment. BC is the part that's just outside the circle, so from point B to point C. And then over here, the whole segment times just the part that's outside, EC times DC. Okay, so see if you can apply that to this problem, and then I'll change the polling results so you can put in your answer here. And if anyone feels confident enough to try it on the board, let me know. I'll give you whiteboard privilege. You can try it out. If not, I'll work it out while you guys are trying it. All right, Tira's going to give it a shot. I'll give you my privilege if you want to use it, but If not, that's okay too. Just go ahead and write it out for us. Thank you. Material's doing a great job. I see a few of you guys have your answer already. If you have it, don't forget to lock it in up there. Very nice. X is 2. And as always, make sure that that's actually what they're looking for, because a lot of times they'll try to trick you, right? And they'll ask you, what is DC? And then you got to go plug it back in. So don't forget that. Yes. Yeah, the fancy way to say that in math is QED. I don't know, it's Latin for something. But anyway, that's actually more for a proof. But don't actually use that in your proof, because we can't say, that would be like, anyway. I'm not actually encouraging you to use that. But just kind of a fun math fact. All right, let's try this one. I saw good, very good. A lot of you guys had that one right. I should ask, does anyone have questions on this one before we move on? Do you guys see how Atiro set that up and solved it? No questions, okay. All right, so always remember that's what this class is for. If you knew it all already, we wouldn't need Class Connect, so don't be shy about asking questions, okay? All right, so 4.11, find the value of AB if dB equals 15 and CB is 4 millimeters. And here's a new formula. So, like I keep telling you in Unit 4, there's so many formulas, it's so hard to keep track of. That's why I made that formula sheet. But here's a new one. Okay, a new one for you to learn. Here's the general concept. If you have a secant line and a tangent line, and you double this, or you square this length, it's equal to the whole secant times just the outside piece. Okay? Oh, yes, I always forget about that, Atiro. Because I don't listen to him as much as you guys do. I forget he says, puts that check mark, and then I am done. Yes, there you go. That's good. That's good. I'm glad you guys watch that, and that helps. That's a great feature of the course. Okay, anybody else want to try this one? All right, Mason was quick on the draw. There you go, Mason. Show us how to do it. Yes, Amelia, maybe next time. Good, so Mason correctly applied that principle. He said, well, AB is the tangent segment, so that's the one that I want to square. So just kind of keep that in mind as you look at this picture. BC represents your tangent piece. And 15 is the entire length of the secant line, and C4 is just the outside piece. So you multiply those together. And then don't forget, if you have something squared and you want to undo the square, yep, Mason has it. You want a square root. And 60 isn't a perfect square root, so you will get a little bit of rounding. Looks like probably C or D. They rounded to the 10th place. Ah, some of you guys are saying D, so let's see. Ah, that's what Mason got too, so very good. Excellent. Give Mason, and we forgot Atiro, sorry. Give both of them a great round of applause. Very nice. You know, Tara, I have no idea. It's hard to say what we'll all be teaching next year. We probably won't know till August. This is kind of how it works from year to year, it seems. But hopefully, because I will miss you guys if I don't have you. So I sure hope so. But maybe even the following year I might have you again. Who knows? Some of you guys have a couple more years. Oh, you guys made my day. Thank you. Well, you guys are awesome students. You truly are. You guys are hard workers in here and come every class and try all the problems and come to tutor time if you need it. So I appreciate your hard work. Yes, yes. Keep it up next year and you guys will be just fine. Oh, thank you. You guys all get A's. See, that's funny because I don't have to give you an A because you guys already have A's. So I can say that. Okay. All right. Oh, yes, I could do that, right, Amelia? Well, you know, the one thing that's interesting is actually for your GPA, it doesn't really matter if you have an A+ or an A. It's all the same, which is kind of a bummer in some ways. You're striving for that A+, but yeah, it actually doesn't matter if you have an A+ or an A or an A-. It's an A, like it's considered an A. So FYI, if you didn't know that. Not that it's bad to work hard. I'm glad you guys are working hard. I don't want to demotivate you, but it's good to know, right? Good to know. All right, 4.12. Now this is more what that video was talking about. So we're getting into equations of a circle. Okay? Yeah, oh, see? Well, I'm glad I told you then. Yeah, you don't have to worry about it. Now, if you go down to a B, then that'll be a different story. But if you're at A- versus A or A+, it's all, as long as you're in that A range, you're good. Yes, I know, Tara. It would be, I think they're talking about like some honors courses maybe or AP courses being weighted higher, but this isn't either one of those, so you don't really have to worry about it. All right, so if your circle is at the origin, what's the origin? Do you guys remember that vocab word? Where's the origin? Oh, you got it, Amelia. I know what you were typing in. 0, 0. Yep, the center. So if you have a X and Y axis and you're right in the middle, that's the origin. So if your circle, the center of your circle is at the origin, this is what your equation of the circle would look like. Okay? Now on the video, well, I'm just gonna skip it. Okay, I'm gonna go to this slide because one, we have a lot of stuff to cover and we're running out of time. But this formula, it looks harder, but it's really the same thing as that one we just looked at, where you were at the center of the circle, except this is more general. This is more helpful because this is going to give you any circle, no matter where it's at, even if it's not at the origin. And that's what that video at the beginning was showing you. So if you guys didn't get a chance to watch it, check it out, but we'll talk about it here as well, okay? So the key things to pay attention to, like he mentioned at the end there, is that you're going to fill in a number for H, K, and R, and the X and the Y are going to stay as X and Y, so they'll stay as letters. Yes, exactly, you got it, Anthony. So this works for all circles, no matter where they are on the coordinate plane, okay? So if the key to remember is the center of your circle is at the point HK. So to fill in the 3 and the 1, you want to identify what the center of your circle is. So in this picture, in this example, we see that the center is at 3, 1. And the 3 is the X value of your center, so it goes in the parentheses with the X. So that's at least easy to remember, right? It's not opposite or something crazy like that. It's just X minus your X value of the center point. Okay. And then the radius of this circle is 4. If you go from 3 to 7, that's a distance of 4, or if you go to 3 to -1, that's a distance of 4, so that's your radius. Keep in mind that it's the radius squared, so that's why this is 16, because that's 4 squared. Okay, but this would be, if the question was, write the equation for this circle, this would be your answer. So you're not going to have answers like x equals 2. Okay, you're going to have an entire formula like this. So if the question says, I know, you're like, okay, but I don't really like that. And I totally hear you because this doesn't look very pretty. But the more you work with it, the more you'll understand where all the pieces go and come from, and then you'll get more comfortable with it. Okay? Now the key thing to be careful with, kind of like, remember distance formula? How the formula at first looked scary, but after you worked with it a while, it wasn't too bad. But remember how I warned you guys that usually where you'll get messed up is with your signs? It's the same thing here, because you have in your equation, let's go back one screen real quick, you have a minus sign in both of these. So if the x value of your center point has a negative in it, you're going to have a double negative. So that's what I'm showing you here on this slide. So if the center was at -2, 4, for example, because the formula has a minus sign and you plug in a -2 for your x, that double negative is going to change to a plus. So your final answer, once you've simplified all your signs, you're going to end up with an x plus 2. So just be careful on those. Watch if you have a negative x or y value of your center point, that you're really careful when you plug that into the formula. Oh, you're still typing it here. Okay, so on lesson 4.08, tell me what happened. Oh, that's not good. Yes, I know what you meant. Can you send me a screenshot of it? Or tell me what part of 4.08 it's not on, and I'll look it up. Atira, you are my expert on finding all the mistakes in the course, which unfortunately there are more than I hoped for. Maybe next year will be better. Hopefully, we keep sending them all that feedback, so hopefully they'll get it. I have gotten a couple emails they let me know, okay, yes, we fixed this quiz, or so hopefully this is the first year that they transferred it to the new LMS, so I think that caused a lot of the errors. There were errors before here and there, but not as many as this year. This year is just really bad. So I do appreciate you guys really letting me know about those, and always hit that send feedback button if you think something's incorrect. Okay, so let's go to a harder example since we're running out of time. Okay, find an equation of the circle with center at -2, 5 and radius 6. So you're going to start with that formula, the general formula, and I don't know, do I have that on the circle formula sheet? I don't think I have this formula on there, but you could add it there if you want to, or do you guys think that I probably could add that? It would probably be helpful. Okay, try, let me write that down. 4.08. Okay, I got it. Sure, I'll take a look at that and see. Thank you very much. Okay, so our h value is just the x value of the center point, and k is the y value of the center point. So we're going to put that in for h and 5 in for k, and that's how they arrive here. So again, just be careful. H is a -2. So you have x minus a -2, which becomes x plus 2. And then we have y minus 5, and 5 was positive, so that usually doesn't give us any trouble. And then don't forget over here that it's r squared, so if your radius is 6, you want to square that. And 36 would be what you put there in your final. So this would be your answer if the question said, find an equation of a circle with center at -2, 5, and radius 6. Okay, so the equation, the whole entire equation is your answer. Okay? All right, let's see. Let's try this one. Okay, do I have maybe a couple people, a couple different of you want to try this one? I'll draw a line down here so we have room for 2 if a couple people want to try this one on the board. Any brave takers? All right, Mason's going to give another one a try. Go for it, Mason. All right, and Amelia. Nice. I turned on the mic if you guys want to use your mic. Maybe Mason, yeah, there you go. Mason's doing the above the line. Amelia, you could do below the line. And the rest of you, let's see, I'm going to turn off the chat box and you guys type in your answer if you get it before they do, and I'll just check your work in the chat box, okay? All right, very good. I think it looks like, sorry. Yes, I was also trying to take a look at, no, good question. Oh, and I have the chat turned off. Mason asked on his problem if he should keep going, and I think what you're saying, Mason, is you're asking if you should take x minus 3 times x minus 3 and FOIL that out. You don't want to do that. You could, but you really don't. You don't have to, because this is better. It's more simplified and factored. Usually when we want an equation, we want it to be as factored as possible, and this is already factored, so we don't want to unfactor it by FOILing. So yeah, just leave it here. And this looks great. So you have x plus 3 squared. I'm not sure what, do you have y minus 8 squared equals 36? I'm not sure what your sign was right there. But very good, yes. And Amelia did a great job too. And Amelia, I wasn't sure if you were done yet or not, so that's why I didn't jump on the mic right away. But these here, you would want to simplify and say x plus 3. But other than that, what you have is perfect. Yep. So very, very nice. Very beautiful job. Yes, and that's why I like you guys to get on the whiteboard, because then we can clarify some of that stuff. So 2 great questions. So Mason asked, do I need to actually square this out? No, just leave it. And then like Amelia stopped there, but you would actually want to go ahead and change that to a plus. Oh, gotcha, Mason. Actually, this is different. That, what you have there, Mason, would be if the 2 is right here in front of that parenthesis. So this means you have, if you did want to expand it out, it would be x plus 3 times another x plus 3. And if you did want to simplify, you'd have to do first, outer, inner, last. But either case, you don't want to do that, so you don't even have to worry about it. So very good. So x plus 3 quantity squared plus y minus 8 quantity squared equals 36. Did you guys know that when you have parentheses around something, you're supposed to say quantity in math? That's how you read it to where people know that there's parentheses around it. Yep, that's, I know, it's kind of strange. I don't know where the wording came up with it, but yep. Or actually, probably to be clear, put quantity first. Quantity x plus 3 squared, and they know that the parentheses around the x plus 3. Yep. Okay, now this question, I want to get to this one at least. I don't think we'll get through all of these slides, but also next week you'll see that oh, thank you, Amelia. There we go. Now it's back on follow. Now you guys are on the same page. Next week, if you look ahead, the Class Connect starts canceled for next week because I'm going to be out Monday through Wednesday, so no tutor times, no Class Connects next week. So what I'm going to try to do, I think we have time to do it, so I'm probably going to move most of next week's stuff, if not all of it, to the following week. So next week will be kind of a clear week because we were supposed to have the Unit 4 test, Part 1, next Friday, and since I'm going to be out, I don't really want to do that. So I think I'll try and move it to the following week so that we can have Class Connect and stuff. However, if you do want to go ahead and keep going, I have tons of recordings from last year, from the year before. So if you're one of those that you're like, well, it's fresh in my mind, I'd rather just keep going, then that's all available. And I have a lot of tutor time recordings as well. And I'm sure you guys know all about that, but you guys like to come to live Class Connects, which I love too. So I don't want you to stop coming, but I do understand if you're kind of like, well, I just want to keep going because I already, kind of have it in my mind. I understand that too. But anyway, at least you don't have to if you don't want to. Okay, so watch for next week's schedule. All right, so here is a little bit different. So now we don't have the radius. So we have the center point, and we know that it passes through the point -1, -4. Okay, but what we're going to have to do is we're going to have to find the radius. And really what this is doing, which really should have been on the board. Let me write this out a little bit more. All you're doing is you're taking this formula for a circle, and you're plugging in, because what you have in this problem is the center point, and that's your h and your k value, right? And then this is actually x and y. So this problem will help you understand what do x and y mean in this problem. So x and y, let's go back to one of the pictures. Okay. This formula, for example, was the equation of this red circle. Okay. What that means is that if you picked an x value, so let's say you picked an x value of 5, and you plugged it in here, and you used your algebra skills to solve it, and you got your y value. What you would find the y value is it would give you this coordinate right here. And if you plugged in an x value of 6 right here and you solved it and you figured out what the y value was, and then you went and graphed that x and that y value, you would get the point right here. So eventually, if you did enough of those, what would happen is you would get this circle starting to get filled in. So this equation means that you can find any coordinate on the circle. That's what this equation would give you. So if you needed to know any x and y value for any point on the edge of this circle, that's what that equation would do for you. So if we go back to this one here, it says that the circle passes through the point -1, 4. So what that means is that you have a circle, and on the edge of that circle you have the point -1, 4. Okay, so you have -1, or -1, -4, sorry. Okay, so right here, your center point is 0, and I could try to kind of sketch it. Let's see if I can do it. I don't know, it's kind of hard to do and illuminate. But anyway, this will kind of give you an idea of what this problem is telling you. You can kind of get a rough idea. If the center is at 0 and it passes through that point, this is maybe kind of what it would look like. Okay? But you're going to be able to find it but that's the key to this problem, is understanding what x and y mean. If you can connect that this -1 is really the x value. It's on the edge of the circle. Okay, the circle passes through that point. So this is my x value and this is my y value. Then what they did was they plugged in all of those, and we're going to be able to find r. Because remember that we're missing our radius here. And so if we plug all that in, we'll be able to find our radius. Do you guys see now on the board what they're doing? I didn't go through all the steps, but can you see how they get to r? Or do you want me to go into more detail? Yeah, and sorry, I would if it were running out of time, but if you plug in -1 right here, and then you plug in -4 here, and then you plug in 0 and 0, you're going to arrive at this step, okay? Yes, or the h and the k are 0. That's what happened. They plugged 0 in here and here because the center is at 0, 0. And so you end up with just -1 and -4. Okay, so then they found the radius, and then they started over, now that they have the radius, plugged in h and k and r, like we've been doing, to find the equation. Sorry about that. So I hope that that makes a little sense. I don't know, but let me know when you get there. You probably haven't gone through the slides either, so yeah, we can practice some more of those after next week, unfortunately. But I mean, or let me know, tomorrow or Friday if you have questions. But next week I'll be out. I will be back. I mean, you can certainly send me a K-mail, and I can answer you guys through that way. But we won't have any live sessions because I'll be out of the office. So let me know if you have trouble. But hopefully, and also don't forget that I do have some recordings from last year, so if you watch those, I might have some stuff there that can help you. I'll go back and look at that in just a second, Atiro. All right, guys, well, I have to head to tutor time, so have a great rest of your day, and let me know if you do end up with any questions, okay?